Hey everyone! So get this, the very same carbon atoms that make you, were actually forged inside a star, billions of years ago. Pretty wild, right? Today we're going to follow the incredible journey of that carbon right here on our planet, a journey that's supposed to be perfectly balanced, but is now being thrown way off course by us.
I want you to think about it like this. Imagine our planet has a bank account for carbon, a kind of cosmic carbon budget. There's a certain amount that can go in and out to keep things stable. Well, the thing is, we're not just overspending that budget. We are racking up a massive debt, and it's a debt that could take thousands of years to pay back.
So, you ready to dive in? First, we'll look at how things got so out of whack in the first place. Then, we'll investigate a really surprising player in all this, farming. After that, we'll take a plunge into the ocean to see how it's handling the pressure. And finally, we'll look at the awesome ways we can start to fix this.
Okay, so for millions of years, Earth had this whole carbon thing figured out. It was like a perfectly choreographed dance, keeping everything in equilibrium. But then, in just the last couple of hundred years, we basically came in and crashed the party. Let's break down how that happened.
So, what does this actually mean in plain English? Well, think of a giant natural piggy bank, like a forest or the soil, that holds onto carbon for centuries. That's a carbon sink. Now imagine taking a hammer to that piggy bank, shattering it, and spilling all that carbon out into the air. That's a carbon source. The problem is, our activities are flipping these natural systems from savers into spenders. Deep under our feet, there's this incredible buried treasure. It's basically a time capsule of ancient life and sunlight. We call them fossil fuels. For eons, they were like sleeping giants, safely locking away carbon that was in the atmosphere millions and millions of years ago. But we decided to wake them up, and that's when we kicked off what you could call the Great Reversal. We took all that carbon that took millions of years to store, and we released it back into the atmosphere in what is, geologically speaking, the blink of an eye. It's like trying to drink from a fire hose of CO2. The planet's natural systems just can't keep up. They're totally overwhelmed.
All right, let's switch gears and talk about something we all interact with every single day, food. Now, you might not realize it, but the soil under our farms actually holds more carbon than the entire atmosphere. This makes farming this incredible, powerful, double-edged sword. It can be a huge part of the problem, or a huge part of the solution.
So you see, agriculture is standing at a crossroads. Is it going to be a carbon polluter or a carbon champion? And the crazy thing is, the choice isn't up to the land itself. It's up to us and the specific farming techniques we decide to use.
Let's look at the ways farming can be a carbon source. Think of heavy plowing, or tillage, as literally cracking open the soil and letting all its stored carbon escape into the air. Then there's monoculture, just planting the same crop over and over. That's like putting the soil on a junk food diet. It gets weak and depleted. And draining wetlands? Whoa, that's like popping a massive carbon balloon that's been inflated for centuries.
But here's the hopeful part. What if we could turn our farms into giant carbon-sucking sponges? Well, we can. It's called regenerative agriculture. And we're not talking about some sci-fi tech here. We're talking about simple things like rotating crops, not plowing the soil, and adding compost. These things don't just grow food. They actively pull carbon out of the air and lock it back into the earth where it belongs.
Okay, from the land, we're going to plunge deep into the ocean. The ocean is really our planet's unsung hero. It quietly absorbs about a quarter of all the extra carbon we pump out every year. But, even heroes have a breaking point, and our ocean is getting dangerously close to its limit. Every single wave that crashes on the shore is like the ocean taking a breath, inhaling CO2 right out of the air. It's this beautiful, natural rhythm that has kept our climate stable for a very, very long time. The problem is, we are now forcing the ocean to hyperventilate. Okay, try to picture this. You have a glass of water, and you start adding lemon juice, just one drop at a time. At first, you wouldn't notice a difference, but if you keep going, that water is eventually going to turn sour. Well, that's pretty much exactly what's happening to our oceans as they soak up more and more CO2. So here's a quick chemistry lesson. When all that extra CO2 dissolves in the ocean, it forms carbonic acid. And this acid acts like a thief. It steals the building blocks, these things called carbonate ions that countless marine creatures need to build their shells and skeletons. With fewer building blocks to go around, their protective homes become thin, brittle, and weak.
Now, when you look at this chart, a drop of 0.1 on the pH scale might not seem like a big deal, right? But here's the thing. The pH scale is logarithmic. That tiny drop actually represents a whopping 30% increase in acidity since the Industrial Revolution. That is the fastest change in ocean chemistry in over 50 million years. This is not a gradual shift, it's chemical whiplash for everything living in the sea.
And this isn't just some abstract science problem. This is a direct threat to the global food supply. When the tiny creatures at the bottom of the food chain, the ones that build shells, start to disappear, the entire system can collapse. That affects everything from plankton to whales, and yes, it absolutely affects the fish that end up on our plates.
Okay, I know that was a lot of pretty grim news, but please don't despair. Seriously, this story is not over. We have the knowledge, we have the tools, and we have the power to write a much, much better ending. So let's talk about the solutions.
We have an amazing toolkit to fix this. We can use that regenerative agriculture we talked about to turn farms into carbon vacuums. We can plant massive forests that literally breathe in our pollution. We can harness the incredible power of the sun and the wind. We can even build machines that act like giant artificial trees, pulling carbon right out of the sky. The solutions are here, right now.
So let me be absolutely clear about this. We are not waiting for some magical new invention to save us. We don't need a miracle. We need action. The science is solid, the tools exist, the roadmap is right there in front of us. The only thing we're missing is the collective will to make it happen on a global scale. So I want to leave you with this one big question. For the last couple of centuries, we've been incredible carbon spenders. The great challenge of our time, of your generation, is to become carbon savers. We figured out how to turn natural sinks into sources. Now, the real test is, can we turn our biggest sources back into sinks? The future really depends on the answer.